Hello, everyone. My name is Shirley. I am the CTO of Dapper Labs and the chief architect of the full blockchain. And I wanted to take some time today to talk to you a little bit about factors that you can think about for protocol design that have to do with usability for both end users and developers. This might seem like a somewhat strange topic because you sort of think of the core protocol as being a very low-level thing that ideally users don't have to interact with. Surely we'll get to a point where users are dealing exclusively with highly polished wallet software and really great dApps that sort of hide away all the complexity that we typically associate with blockchains. But it turns out that there's sort of certain things that even great UX can't hide, and if you don't design the protocol with usability in mind, you can end up limiting some experiences or making some complexities inherent to the experience. So I want to talk about a few of those that we thought about for Flow and we're integrating into Flow. So the first one from a user standpoint is breaking that link between an account and your keys. So when Satoshi designed Bitcoin, they focused on this idea that that all of your coins are locked behind keys, and the mindset in that design was that you might use different keys for sort of different sets of tokens that you might have, and you might have like a whole array of keys. But if someone was sending you tokens, they needed to have some sort of account identifier to know which keys were associated with those tokens so you could unlock them. And of course, that general design is carried over to other blockchains. And on Ethereum, your account identifier, your account address, is derived from your public key. The reason why this is problematic is that keeping your keys long term is actually quite problematic. I had a situation where I had copied, had a recovery, 3 different pieces of paper as a recovery option for my keys, and you needed 2 of 3 in order to recover the key, and I lost one. And so, proper etiquette in that case, proper procedure in that case is just, cycle your keys. Odds are no one's going to be able to brute force the key with only half of the key information, but you want to make sure that's not likely to happen. But cycling keys on Ethereum is a huge pain in the butt if you have anything more than a couple of tokens. If you have a bunch of CryptoKitties or some other NFTs, the amount of transactions and gas costs it takes to move all your assets from one account to another is massive. And so one of the things that we did in Flow is we made sure that your account has nothing to do with your keys. You can have any number of keys associated with an account. You can change your keys at any time. And we even built multisig into the account model so that if you want to have multiple keys with different weights and require, sort of a 3 of 5 system for transactions to be signed, that's all built into the account model. The other thing that that is hard to sort of abstract on top of a blockchain if it's not built in is the notion of a multi-action transaction. So most blockchains, when you submit a transaction and you can have it do some action, you can have it transfer some tokens, you can have it interact with the DEX, you can have it maybe go buy an NFT. But what if you want to do multiple things? What if you want to take some tokens in your account and exchange them for a different kind of token on a DEX, and then use the resulting tokens to go buy an NFT because the NFT is being sold in a token that you don't normally hold in your account? Well, on Ethereum, of course, you're certainly welcome to go to the DEX and do the exchange and then take the results of that and go to the NFT marketplace and buy the NFT there. But what if the NFT is gone by the time that the token conversion happens? Well, now you have to convert your tokens back to the original asset that you held, and you might, be losing some exchange rate going both ways. If we could have a transaction that could do multiple actions within a single transaction, you could have a single transaction that goes to the DEX, does the exchange, takes the result of that exchange, and goes to buy the NFT. And if the purchase of the NFT fails, the transaction fails. And if the transaction fails, then everything about the transaction gets reverted, including the purchase of those tokens. And so it's as though nothing happened. And so making sure that, so one of the things we built into Flow is that we made sure that a transaction can be arbitrarily complex. It can have any sort of number of steps in it, so that if you have a multi-step process that you want to do and you want to do it atomically, you can do that in a single transaction without having to deploy any code to the blockchain. Of course, this raises another issue, which is, as a user, how do I even know what a transaction is doing? I go to a DApp website, it proposes a transaction for me. If that transaction is very simple, then of course the wallet software can assure me that it understands what's happening in that transaction. When we open the door for these complex multi-step transactions, suddenly it becomes very difficult for the wallet software to sort of analyze that transaction and say, well, what's really happening here? And so in Flow, we actually designed the transaction to be in multiple parts. So we have what's called the prepare statement, then we have the main execution block, and then we have a post condition as well. And what happens is that it is only during the prepare statement that the transaction has access to the assets in your account. And that prepare statement can be very small. So using my example from before, maybe that's where it takes 50 tokens out of my my main account that it's going to eventually go and send to the DEX and then use the proceeds to buy an NFT. And so during that prepare statement, we do something very simple, which is take 50 tokens out of my account. All of the rest of the actions happen in that execute statement, going and talking to the DEX, making sure that the exchange rate is within bounds of what I expected, using the proceeds after the exchange to go and buy the NFT, taking any change from either of those, any leftover funds from either of those exchanges and depositing it back into my account, and of course taking the resulting NFT and putting it in my account as well. All of that can happen in the execute statement. And so the wallet only has to look at that prepare statement, and it can know with absolute certainty that this transaction, even though I've signed the whole transaction, that the contents of my account can only be accessed in that prepare statement. And so that transaction, no matter how complicated the execute statement is, can only touch 50 of that one kind of token that the prepare statement pulled out. So that's very powerful. And on the backside, we have this post condition. And what that means is that you can put any sort of assertion in there. In this case, it would be, say, the presence of the NFT I wanted to buy in my account. And so it could have as a post condition, look, if this, this NFT should be in my account. And the way the blockchain works is it runs that prepare statement, taking the assets out of my account. Once those assets, the prepare statement is over, my account is locked down, and that transaction has no special access to my account at that point in time. The execute statement runs. It can be arbitrarily complex, but it's not running with any special privileges. It only has access to the assets that I gave it access to in the prepare statement. And then when the post condition runs, it makes sure that the result I was expecting has happened. And if it doesn't, again, it reverts the whole transaction and everything goes back to the way it was before the transaction even started, which means as though those 50 tokens didn't even come out of my account in the first place. And so the wallet can ignore the execute section entirely and just look at that prepare and post condition. And it can tell me with great confidence that this transaction I'm signing, at most, it's going to take 50 tokens out of my account, and it's guaranteed to result in me having that NFT in my account, or nothing having happened except for me paying the gas cost of running the transaction. The other thing that we added to Flow, and this was of great importance after what we saw happening with CryptoKitties when we launched, the blockchain was completely overwhelmed, and people were running into all sorts of problems where their transactions would take a long time to resolve. And so Flow transactions can expire. And what that means is that the wallet software can set any sort of expiry time it wants, 10 minutes or less. And it can say, look, this transaction, either it will be included in the blockchain in the next, let's say, 2 minutes, or this transaction is invalid and it can't ever be included in any blockchain ever. Now, it might seem like that's a bad thing. Like, well, maybe I want it to wait 5 minutes, 10 minutes. Maybe I want this thing to happen half an hour from now. But that's okay, because my wallet software can actually just, every time it expires after 2 minutes, it can issue a new one, because a transaction that isn't processed, of course, doesn't cost anything. And so when that transaction expires, it can just issue a new one silently in the background. And the whole time it can have a giant cancel button for me in the UI. And if I click that cancel button, of course, it knows not to reissue that transaction on my behalf. And so I can know with great certainty as an end user, either that transaction resolves within 2 minutes, or it will never resolve. And I don't have to do any, replace by fee or anything like that if the transaction doesn't resolve in that first minute or two, because I know that it's expired and it's now would be considered invalid by the blockchain. The other neat thing we did in Flow is that we actually put your stuff in your account. That seems like a crazy statement. Of course, blockchains, where else would your stuff live? But it turns out that most blockchains, and predominantly Ethereum, both the ERC20 and ERC721 specification, work on a ledger model, which means that there is a central ledger. Ironically, on a decentralized system, there's a single central ledger managed by the smart contract, and it keeps track of which assets each user owns. So if I own CryptoKitty number 852, then there is an entry in the ledger, CryptoKitty 852, and next to it is my Ethereum account. Now, this might seem like it's not that big of a deal, but it turns out that with this model, it's actually kind of complicated to figure out what you own. You have to go to every single ERC 721 contract and ask it, well, does this account own something in the account in this smart contract? And then you go to the next one. Does this account own anything in this smart contract? Same for all of the ERC 20s. And of course, as time goes on, we're not going to have less of these things. It's just going to be more and more and more. And so the complexity of finding out what you own is going to just keep getting greater and greater. And of course, most of those queries are going to come up nothing because you don't own most of those things. The way we manage it in Flow is actually all of your assets live inside your account. And so if you want to know what things you have in your account, they're all right there. Even more importantly, all of the approvals that you've given to let people access items in your account on your behalf. For example, maybe you've created an arrangement with an online exchange to sell NFTs on your behalf. And you're willing to trust that smart contract to withdraw NFTs and sell them to people on your behalf, provided that it confirms that you accept that price. Well, those approvals, again, on Ethereum, all of those approvals are stored in the smart contracts where you put them. And so if you forget that you've put in an approval, that approval might sit there latent for a very long time. On Flow, all of those approvals are actually represented in your account, and they can be fully enumerated so that you know exactly what's in your account and sort of who has access to it. The other thing that we spent a lot of time thinking about on Flow was how to make life easier for developers. And one of the first things we did, in fact, we made this available publicly before the blockchain was even completely running, was something we call the emulator. When you're developing software, needless to say, you don't get it right on the first go. And there's a lot of testing and iteration that goes on in order to make sure you get that smart contract right. So one of the things we wanted to do was make sure that that was super easy. And so we created this standalone binary we call the emulator, and it lets you deploy smart contracts, run transactions. It provides the same, sort of gRPC API that the primary blockchain does. So you can even test your off-chain interactions with the blockchain, all running this emulator that runs in a very small memory footprint and launches super quick. And so that makes testing, debugging so much easier. And of course, one of the interesting side effects of this is that because we built this standalone emulator, we were able to take that code and we were able to embed a version of that onto our website. So if you go to onflow.org/play, you can find a playground, and you can go there and you can see samples of fungible token, non-fungible token smart contracts, and you can run them right inside the browser, make changes to them, see what the results are, have multiple simulated accounts, and see what happens as you move assets between those accounts. And I think it makes the whole system more approachable. The other thing, and speaking of the Flow playground, the other big thing we did was we made sure we created our own smart contract programming language. So this might seem like a kind of a crazy idea, and I think if you've never written code for Solidity before, you might be very surprised that we would do this. But I'll tell you what, most people who have worked with Solidity, when I tell them that we decided to write our own smart contract language, their reaction is less confusion and more, oh, thank God. So the reason we did this was because we felt that there had to be an easier way. I think, we're probably the only blockchain development team who started by building applications on top of blockchains rather than started by building blockchains. And so I think we have a lot more empathy for the plight of the poor dApp developer. And so we built a language that is designed from ground up to make sure that it makes sense in the context of blockchains. In the context of blockchains, there are two really critical aspects that you need to deal with. One is this notion of valuable assets, moving tokens around, moving NFTs around, and the other one is just this idea of access, right? No one should be able to move my tokens but me. And so we baked into the language primitives for handling ownership and access controls. That's built right into the language, and the result is something that is, I think just a dramatic improvement. And I can give you a really concrete example of how that's manifested. So for example, the Open Zeppelin reference implementation of ERC20, beautiful code, very neatly written, well documented. It's about 300 lines of code, but it's, like I said, it's very well documented. So there's probably maybe 150 lines, 150 lines of sort of actual code in that thing. But it's sort of, the most basic, simplistic, correct implementation of ERC20. Most people use that as a basis when they're building a new ERC20 smart contract. By contrast, if you go look at what is happening in Rust, I found a simple ERC20 equivalent fungible token implementation for the Cosmos network written in Rust, and that was almost 400 lines of code. And that was 400 lines, and I didn't see a single comment in the whole thing, and I found it actually pretty intimidating and densely and complex. And so, it doesn't seem like going to Rust and WASM is a real improvement here. In Cadence, our reference fungible token implementation is just over 100 lines of code. If you take out the comments, it's less than 100 lines of code. It's about 70 lines of code. So that's about half of what Solidity is. So broadly speaking, Rust, twice as many lines of code to do the same thing. Cadence, half as many lines of code to do the same thing, Solidity. And so we think that that's a huge improvement. Unsurprisingly, if you know us, you'll know that that we looked at NFTs as well, and NFTs are even easier. If you look at the ERC 721 reference implementation from Open Zeppelin, again, very beautiful, well written. It's even longer than the ERC 20 specification. It's a little bit more complex in Solidity to deal with non-fungible tokens than it is to deal with fungible tokens. In Cadence, it's actually the exact opposite. The non-fungible token specification is simpler than the fungible token specification because, again, we've built into the language this idea that there are certain data structures that represent assets of value, and that's managed directly by the language. So hopefully you can see from this that by coming with some empathy for our users, both our developers and our end users, that we were able to bake things into the protocol that's going to make their lives so much easier over the coming years and decades that we hope that Flow will be used.